Hello. So we're going to get started with the first session that's actually not on the printed agenda, which is a presentation by Maroon from Prolane, who's going to talk about how they're using RIST in the Middle East and the successes they have had with that. So welcome up to the stage, and then this will be 20, 30 minutes, and then we'll kick off the ordinary agenda at 1. But feel free to continue eating in the meantime.
Thank you. Hello, good afternoon. Let me just introduce myself. I'm Maroon. I'm working for Prolane. I have 17 almost years in the experience in the industry. From production to media, as well as digital transformation. And now we're moving to the IP connectivity. So we'll go a little bit through some introduction about what the company is doing now, as well the deployment of RIST, of course. Mainly, Prolane is a company based in UAE, in Dubai. It's since 2009. Mainly we are system integrators. Then we upgraded our activities to do services for broadcast as well as production. Starting from 2014, we started the new platform, or sort of providing a solution related to IP connectivity for contribution and distribution. We have like around 50 to 60 clients as TV stations, as well as like 15 clients for production as media productions and agencies. Usually what we are providing is, other than the solution, we provide consultancy to sort problem for digital transformation now. Now we'll talk mainly about the platform that we built, and we are doing the video connectivity for contribution and distribution. Usually the platform is called the Streamlane. Under Streamlane we have 3 items, or 3 blocks, let's say. We have the Surge, Solve, and Sprint. Surge is the encoder. Solve is the decoder. As well, we do the playout and ingest solution. We have many teleports and telcos that we have already installed. We have our system installed at it, which is some people, they have the playout system and decoder. So the main strengths of the solution, which is that we are available in different nodes. We have our data centers. As well, we have the endpoints, which is easy for broadcasters to, once they need to convert or use our solution, they can move from one provider to another's. So we have the playout solution available on premises at the client side, or at the teleport, or at the telco side. This is our device as encoder or playout, or it's the same device with the Streamlane. We're just changing the solve if it's the decoder side or encoder. We're doing MPEG-4, AVC, low latency, using ARQ, which is using RIST nowadays. Our system is, of course, having the RIST system, and we have above it the open broadcast system. We're using their application to put it on the server to do the connectivity. As well, we have the third-party integration, which thanks for RIST that is doing that, and we have some proof of play for that connectivity between our platform and others, especially with Atom and Zixi, and as well with Net Insight, the Nimbra one. Our connectivity, as distribution and contribution, is available in these areas, which is we have connectivity from Lebanon to Cyprus, from Algeria to Jeddah, as well as between UAE and Oman in Muscat. So as well, we have a testing is going on now to Istanbul and to UK. Now I'll move to the RIST. Why we decided to deploy the RIST. Mainly, when we start the business and we create the solution, we faced a lot of problems especially in our area, because in the Middle East we have a lot of poor infrastructure in some countries. It was a mess just to convince people, and the client that why he should use the platform of video connectivity on the public or unmanaged network. This is one. Versus the satellite one, because mainly what we are trying to do is to move from satellite to IP connectivity. First, because about the reliability of RIST, which is make us very flexible to deploy our API and to add different features that is needed from or requested from our client in the Middle East. The easy of deployment, which is kind of plug and play. It was very easy to do it. The high quality of delivery. We were surprised mainly about the high quality, how much the quality is, and the low latency. Because mainly we start with using the Atom devices. Of course, now we are playing in the round of ARQ. So because the FEC, it didn't work. We tried the SRT as well, it didn't work in some areas. So the flexibility, how much it's flexible to go from a requirement to another, as well the adaptivity of the connection, of the bandwidths, which is sometimes we're doing like less than 2 meg for an SD channel, which is coming with very, very good quality as receiving versus the satellite. Then we're talking about the stability, and for us, it came like a room to change from a technology to another in our platform. Now, in our opinion, that especially in the Middle East, the broadcast is taking the new shape, because we had, despite from our platform, we did several projects for IP connectivity between different area as a LAN, from like studio to another studio, one place to another. We deployed it and it works. To have like we are starting in the remote, in the production remotely. So now the market, in our opinion, it needs a flexibility. That's why we were convinced in the RIST, because as you can see, like Adobe, how there is many companies is playing around for providing like services above Adobe for post-production and Avid. So I think for that area, when we talk about internet and video connectivity, RIST is doing that change, that it's provide us, to the option to have a more access to the client, because our main client, sometimes it's easy for us to change for the client side, tell him, okay, come and we provide you a video connectivity if you don't have any infrastructure. But some of them, they have already something. They have the infrastructure and they don't want to pay. For example, you have a client that, let's say he has a Net Insight device and he needs our service. With RIST, it's coming much easier to tell them, okay, keep your device and just add on above it our service, which is, it makes sense. Now I just need to show you, like we did a monitoring with a snapping on the devices from different locations with different buffering system. So that's it. Here we can see, these, by the way, they are real numbers, and they are they are on air, right? So here we can see the packet. It's just like a 30 minutes, 30 seconds video. You can see the packet received versus the packet recovered using the RIST. And you can see that there is no packet loss, which is, it was very stable. Here you can see that on full HD, as a buffering of 300 milliseconds, you can see that there is no packet loss. Just we have this small amount of packet loss versus the amount of packet received. And you can see the other one with the SD, which is 500 milliseconds. It's very stable. And you can see how much the network is bad. You can see the amount of packet recovered, how it's recovering. So this was like our proof that the RIST is working fine, especially in that area between, let's say, for example, from Syria to the UK. And if we need to trace the IP, you can see that the turnaround is horrible. So the IP will start from the source, going to the US, then to the UK, then it reaches the destination, wherever it is. Now, what's our challenges? In the past, as you know, that the IP was not a platform that is trusted, and the countries are trying to involve it and try to each one as per his budget. So everybody was going through the satellite contribution and satellite connectivity. In some cases, they were going through fiber, MPLS, our traditional, and leased line, our traditional connectivity. Now, since like 3 years or maybe less, people, they are willing to hear and understand, and they are open to a solution over IP. So there is one more factor that's led them doing this, is they need to reduce their cost. They need to reduce their budget all over the year. So now it's coming a solution that is good. The client is open to hear it. As well, we had the challenge now with the RIST, in our understanding, is that we need to innovate, because the system give us a room to provide more APIs or more maybe APIs or more maybe more features to the clients. Depends on what the market is in need. So it's our job to innovate, to think more about any solution that can reduce the cost on the client side, as well as providing new features that you have to be ready for that future that is coming. Especially the 5G is on the board, we believe. I think within 2-3 years it will take place, and somehow. What's next in our platform? Now we are working on some specific features which have requirement from the client, that we're working to add on the decoder side using the RIST, trying to make a transfer of data, to have some, regardless the buffering, to store some media inside the system. So in case of failover, so it can automatically play the system. It just can be like, it's just replacing of the off time. Can be a promotion or can be a logo, depends on the decoder capacity. And the other way, we're looking to provide a watermark. This requirement is for distribution, because a lot of agencies, they are pushing their content. They need to secure it somehow. So and people, they don't want to see the black screen when they have a registration with some agencies. So we're working for a capability to push a watermark with the device. Upon subscription, the client can remove that watermark, and this one will give extra monetizing for the agency in a way that instead of having a subscription for all over the year for open content, it's fine for them to sell it per video. So he can see the video, the client can see all the videos, and he can just decide that I need that video. So once that video is confirmed, within one click, the watermark will goes off, and he have the clean feed. And the last point, which is because we have a lot of failover, we're working to find a solution using RIST about the 1+1 or 1+n to find a way for a failover, which is coming out sometimes mainly 1+1 from the source and sometimes to have it on the cloud. But the problem is just to synchronize the delay from the source to the destination. Because in case of failover, if we're doing something through the cloud, we're facing a problem, which is that we're having like around maybe 10 to 12 seconds delay with the content coming from the source. What I mean is that if we are playing out from X on premises, then we have the failover on the cloud. We're having like something related to 12 or 15 seconds of delay. Mainly, that's all what we need to talk about.